Okay, this is the fourth lesson in the algebra series. Right. So today we are going to introduce polynomial functions. Right. This is a very important function in algebra. Right. A polynomial function of degree n. Right. This is an important word. Degree n is a function of the following form. Right. It has to have this form. P of x is equal to a n x to the n power a n minus 1 x to the n minus 1 and keep on reducing the power until you get a1x plus the constant term. Right. So now some important things about n. N is what? N is a non-negative integer. Okay. N is a non-negative integer. That means either 0 or any positive integer. Okay. N cannot be fraction or negative. Okay. It has to be non-negative integer. So these powers are all positive powers or zero power. Zero power means the constant term. Right. And these numbers a0, a1, a2 up to an are all real numbers and they are called what? Coefficients of the polynomial. Okay. And there's a special condition. An has to be non-zero. Right. What is the degree? Degree is the power of the highest power term. So here highest power term is x to the n. So power is n. So that is why we call this a degree n polynomial. Right. So remember the condition. N has to be non-negative integer. Right. Okay. Let me write down some functions and let's figure out which ones are polynomials, which ones are not polynomials. Another one. Let's do that one and another one like this. Right. So here I have written down 5 functions. Let's figure out which ones are polynomials, which ones are not polynomials. Right. So let's look at the first function f(x). Look at the powers. All of them are non-negative powers. Then it's fine. It's a what? It's a polynomial function. It has this form. So first one is fine. And what is the degree of this polynomial? If it is a polynomial, it has a degree, no? Degree is the highest power. So this is what? This is degree phi polynomial. Right. Now let's look at the second one. We have x cube, it's fine. Constant term fine, but here it fails the polynomial function requirement. It has a negative power. All of these are what? Non-negative powers. So this can't happen. So because of this negative power, this is not a polynomial, right? Then look at the third one, h of x. Minus half x is fine, x to the 1 power, no? But the issue is this one. you have a fractional power half. So that's the issue here. So it fails the polynomial requirement. Right. Then let's look at the fourth one. X to the 100. Any power, non-negative power is fine. Minus x to the 5, fine. 3 over 2x is fine. The constants can be any value, positive, negative, fraction, it's fine. Only the powers you have to worry about the number. It has to be a non-negative number, right? So this is what? This is a polynomial. What is the degree? Highest power is 100, no? So this is a 100-degree polynomial. Let's look at the final one, 5. Constant is also a polynomial because 5 is same as 5 times x to the 0 power. Non-negative integers, no? So 0 is a part of that. So this is what? This is a polynomial of degree 0, right? So first thing we need to know is how to identify polynomials, right? Now we have an idea about that and we know how to identify the degree of the polynomial, right? Then let's look at the other bullet points given here. Number a naught. This is this form is also called the standard form of the polynomial. Remember that also, right? A naught is the constant term, one without the x. Okay, it's also called constant coefficient. Then number an, which is associated with the highest power term, is called what? Is called leading coefficient. This is a very important thing when we are doing polynomial division. And the term is called what? That first term is called leading term. We are going to use that to do polynomial long division, right? Then another important fact about polynomial functions are the domain of any polynomial is all real numbers. So you can put any x as an input, you will always get an output value. So remember that any polynomial, whatever degree, the domain is all real numbers. So fx, we know it's a polynomial of degree 5. Domain is all real numbers. This one, mx, degree 100 polynomial, it also has a domain of all real numbers, right? Okay, then let me write a example. Right, let's take this as our polynomial. Right, so let's identify important terms. What's the constant term? Constant term is 100. Sorry, not 100. We have to take the sign into account also. So minus 100. What's the degree? What is the highest power? 5. So the degree is 5. So this is a polynomial of degree 5. Then leading coefficient and the term. Leading term is what? So leading term is the term with the highest power, the full term. So that is 4x to the 5. Then leading coefficient is what? Number associated with the highest power. So what's that number? 4. So you should know how to identify these terms of a given polynomial, right? So now we have defined polynomials. Now let's look at some properties and some algebraic operations of polynomials, right? First, let's define some special polynomial functions, right? Polynomial of degree 1 is called a linear function. So it has this form, ax plus b, where a, b are real numbers and a cannot be 0. What happens if a is 0? Then it's a constant function. No, that's a degree 0 polynomial. Okay. So that is the reason a cannot be 0. Right. Then polynomial of degree 2 is called what? Quadratic function. Right. And it in that a, b, c are what? Real numbers, and a cannot be 0. Again, the same reason. If a is 0, this becomes a px plus c, or a polynomial of degree 1. That is why a has to be non-zero. Then cubic function is a polynomial of degree 3. So polynomial of degree 3 is called a cubic function. So ax cube plus bx squared plus cx plus d form. This is the general form of a cubic function. A, b, c, d are real, and again a cannot be 0. Right. So for example, this is a linear function because degree 1. Then this is what? This is a quadratic function because it has degree 2. Right. This is what? Degree 3 polynomial. So it's the cubic function. So all terms doesn't need to be there. So here x squared coefficient in this cubic is what? 0. X coefficient is also 0. Okay. So all terms doesn't need to be there. Okay. Remember that. So simply putting, this is also cubic because x cube, right? It's a polynomial of degree 3. Here x squared coefficients, x coefficient and constant are all 0. Right. Okay. Right. Now another important concept, polynomial equality or equating coefficients. Right. So here we are going to look at two polynomials, px of degree n and qx another degree n polynomial. So they have to be the same degree. Remember that. Okay. Right. Now I want to find a condition for these two polynomials to be equal. So I want px to be equal to qx. Right. It can only happen if this is true, first of all, same degree. So for example, cubic and a quadratic can never be equal because they have different degrees. Okay. Only polynomials of same degree can be equal. Right. So that is the first condition. So px is equal to qx if and only if this is true. ai equals bi for I equals 0, 1, 2, n. So what does that mean? Coefficient of the nth power, that is an, has to match the coefficient of the nth power in the qx, that is bn. So similarly n minus 1 should match bn minus 1, a1 should match b1, a naught should match b naught. So corresponding coefficients should match. Every corresponding coefficient should match. That is the condition for polynomial equality. Right. So it is mentioned here, two polynomials are equal if and only if what? They have the same degree. So what? That is the first condition. It has to have the same degree, and corresponding terms have what? Equal coefficients. Okay. Corresponding terms have to have equal coefficients. So the constant terms should match. b1 and a1 should match. an minus 1 and bn minus 1 should match. an and bn should match, like that. Okay. So let's do a simple example to illustrate this. Let's say this is given to us. Right. Okay. This is given to us. If this is true, find A, B, C, and D. Right. So look at the left hand side. It's a degree 3 polynomial. Right hand side is also degree 3 polynomial. So they are saying this is true. So that means these two polynomials are equal. So then what is the condition? Each of the corresponding coefficient should match. So start by comparing x cube coefficients. So what is the x cube coefficient on the left hand side? 2. So 2 should be equal to what? Right hand side x cube coefficient, which is 2a. So now you can solve for a. So a is equal to 1. Right. Then we will compare what? X squared coefficients. Right. So now look at the left hand side. There's no x squared term, no. So that means what is the coefficient? Coefficient is 0. You can, if you want any missing term to make calculations easy, you can write it like this. Put a 0 x squared. So 0 times something is always 0, no? So doing this doesn't change the left hand side. Okay. So the left hand side x squared coefficient is 0, right? Then what is the right hand side? B minus 2. So 0 has to be equal to b minus 2. So then b is equal to what? B is equal to 2, right? Then let's compare x terms. Minus 3, the coefficient, we have to take it with the sign. What is in front of x? Minus 3. On the right hand side, it's what? C. So what is C? C is equal to minus 3, right? Then finally we will compare constants and find D, right? So left hand side constant is 5. 5 should be equal to the right hand side constant D minus 1. So 5 equals D minus 1. So D is equal to 6, right? So this is a simple application of comparing or equating coefficients. When two polynomials are equal, we can do this. This is a technique you should know. Okay, this is a very important technique. When we are doing partial fraction decomposition, we are going to use this technique, right? Okay, let's do a more advanced example using equating coefficients, right? Okay, so look at exercise 1. They have given this expression: 6x cubed plus x squared plus 10x plus 8 is equal to this 3x plus 2 times ax squared plus bx plus c, and we are supposed to find a, b, and c, right? So look, left hand side, it's clear, it's a degree 3 polynomial. Right hand side, it's in factored form. First one is a linear function, the second factor is a quadratic. So we have to first get rid of brackets and write it in the standard form of a polynomial, that is this form. Then after writing it in this form, we can start comparing coefficients and get the ABC values, right? So the first thing you should do is get rid of brackets. So you get what? 3a x squared, x cube, 3ax cube, 3bx squared, 3cx, 2ax squared, 2bx, 2c, right? Now simplify the left hand side, sorry, the right hand side. So That means combine like terms. So x squared terms combine. Similarly, combine the x terms and the constants and any other terms you can combine. Right. So then we have what, 6x cubed plus x squared plus 10x plus 8 is equal to 3ax cubed. Combine the x squared term, so you will get 2a plus 3b x squared. Then combine the x term, so you will get 2b plus 3c x plus 2c. Right. Now right hand side is in standard form of a polynomial, and it's also a degree 3 polynomial. It is equal to the left hand side degree 3 polynomial. So we can now start comparing coefficients and get the answer. So then 6 equals 3a, a equals 2, x squared, you will get what? This is what x squared means. It's same as 1 times x squared, so the coefficient is 1. 1 equals 2a plus 3b. So you know what is a is 2, so 1 equals 4 plus 3b. So 3b equals minus 3, or b equals minus 1. Right. Then we want to find c. There's two ways of finding c. You can either compare x coefficients, so then 10 equals 2b plus 3c. But what's easier? You can just compare the constants. Then you get 8 equals 2c. That is easier to solve. So I'm going to do that. Constants. So using the constants, I will get what? 8 equals 2c. So that is equal to c equals 4. Right. So then a equals 2, b equals minus 1, and c equals 4 is our final answer. Right. Okay. So now next we are looking at what? Algebraic operations on polynomials. Adding and subtracting polynomials is what we are first going to look at. So this is very simple. Combine like terms and simplify and write it in standard form. Right. So let's do a simple example. Look at exercise 2. We want to find sum and difference of polynomials px and qx. Right. Let's do that. So px plus qx. What is that going to be? So first write it down. 6x cubed minus 2x squared plus 7x minus 4 plus what? X squared minus 10x plus 8. Now add the like terms. So combine the like terms. So what are the like terms? X squared terms, then x terms, then the constant terms. So let's do that. Right. So we get 6x cubed minus 2x squared plus x squared becomes what? Minus x squared. Then the x terms, 7x minus 10x becomes minus 3x. Then the constants, minus 4 plus 8 becomes plus 4. Right. So that is adding polynomials. Then subtracting polynomials, px minus qx. Right. So then again let's write them down. 6x cubed minus 2x squared plus 7x minus 4 minus subtracting, okay, x squared minus 10x plus 8. Use the brackets, then it's easy because you won't make mistakes when you are distributing the negative power. Otherwise sometimes you will make errors with the signs. Right. So let's do this. 6x cubed minus 2x squared plus 7x minus 4. Distribute the minus sign, so you get minus x squared plus 10x minus 8. Right. Now like in the addition, combine the like terms. So we have what? Minus 2x squared minus x squared plus 7x plus 10x minus 4 minus 8, the constants, right? So let's write the final answer by combining 6x cubed minus 2x squared minus x squared becomes minus 3x squared plus 7x plus 10x becomes plus 17x minus 4 minus 8 becomes minus 12, right? So that is the answer for the difference of these two polynomials px and qx, right? Now let's look at product of polynomials. So we did addition, subtraction, next operation is product of polynomials. So get rid of brackets, that is just what we are doing. So we already did this actually in exercise 1. The right hand side is what? Product of polynomials. Now first bracket is what? Degree 1 polynomial or linear function. Second bracket is what? Quadratic or degree 2 polynomial. So when it's a product of two polynomials, no? So what did we do? Got rid of brackets and combine the terms. So that's the method, right? So let's see, px times qx. So then we have 6x cubed minus 2x squared plus 7x minus 4 x squared minus 2, right? So let's get rid of the brackets. So you get 12 x to the 5 minus 12 x cubed minus 2x to the 4 plus 4 x squared plus 7x cubed minus 14x minus 4x squared plus 8. Right, we are going to get 8 terms. Now combine like terms and simplify. So you have 12x to the 5 minus 2x to the 4. Is there any other way we got x to the 4? No, so only that. So minus 2x to the 4. Then look at the x cube terms. Minus 12x cubed plus 7x cubed. So minus 5x cubed. Then the x squared terms. This one 4x squared and minus 4x squared, right? That one you can cancel. So there's not going to be x squared terms. So we did x5, x4, x3, x squared. Now only x terms are left. So this one minus 14x and the constant plus 8, right? So that is the answer, right? So product of polynomials is done like that. Get rid of the brackets, right? So we did addition, subtraction and product. Then to do division we need to first introduce rational functions. Okay, so let's first introduce what is a rational function, right? Function fx is a rational function if it has this form: fx equals p of x over q of x, where this is the important thing: p and q are polynomials and qx is not equal to 0 because you can't divide by 0. So a polynomial divided by another polynomial is called a rational function. Okay, right. So then how to find the domain of a rational function? Domain of fx is the set of all values of x for which what? Denominator is not equal to 0. Denominator of qx, qx, which is the denominator, is not equal to 0, right? So let's do an example. So how to find the domain of this rational function. It's clear this is a rational function. Why? This is what? Degree 3 polynomial. Denominator is degree 2. So polynomial divided by a polynomial is always a rational function, right? Okay, now let's find the domain of this rational function. Right. So first thing you should do is factor the denominator, because we want to find the points where the denominator becomes 0 and get rid of those points. That is how you find the domain of a rational function. So x squared minus 1 is same as x squared minus 1 squared. So what's the formula? Difference of squares. So you get x minus 1 times x plus 1. So that means what? We can equal this to 0 and get x equals 1, equal the second factor and get x equals minus 1. So when x equals 1, what happens? If you substitute x equals 1, this is 0. So therefore the denominator becomes 0. So we have to get rid of x equals 1 from the domain. Similarly, substitute x equals minus 1. This will become 0. So the denominator becomes 0. We can't divide by 0. That means we have to get rid of minus 1 from the domain. So what is the domain then? Domain of fx is what? All real numbers except which two? Minus 1 and 1. You have to get rid of those two. Minus 1 comma 1. So this same thing in interval notation is what? Negative infinity to negative 1 parenthesis, because we don't include minus 1, union minus 1 to 1 parenthesis again, because we don't want to include the endpoint 1 comma infinity, right? So here this answer is wrong. The interval notation, correct interval notation is this one, right? Okay, so how to find the domain of a rational function should be clear. What should you do? Factor the denominator and get rid of any points where the denominator becomes 0, right? Okay, then now we can get into division of polynomials, last algebraic operation for polynomials, right? So dividing polynomials is similar to number division. So let's look at what we do when we divide 41 by 9. 41 is what we put inside the division sign or the division box. So that is called what? Dividend. Okay, number we put inside the box or the number we divide is called dividend, right? Then we want to divide 41 by 9. So then the number we put outside of the division sign or the division box is the divisor, the number we divide by. So that is called divisor. So what do we do first? We look at how many 9s inside 41. How many? 4, right? Then what do? We multiply these two, 4 times 9, and put it under the dividend. So that is 36. Then what's the next step? We subtract for these two numbers, you get 5, right? So are there any 9s inside of 5? No. So that means this is the whole number part, rest is the remainder. So what you get up here is called what? Quotient, and down here is called what? Remainder, right? So then we can write this as what? 41 divided by 9. You get what? Answer part is 4. You get 4 whole points plus what? A remainder part, 5 over 9. This can also be written in this way. Get rid of the divisor, 9. So you can write 41 is what? 4 times 9 plus 5. Correct, no? 36 plus 5 is 41. Right. These two ways of writing the number is called division algorithm form. Division algorithm form, right? So in the division algorithm form, what you do? Dividend over divisor equals quotient plus remainder over divisor, or in the second form, dividend equals what? Quotient times divisor plus the remainder, right? Okay, so remember these names of these terms. Okay, what you put inside is dividend, what you divide by is the divisor, what you get up here is the quotient, down here is the remainder, right? Okay, now let's formally introduce division algorithm, right? Very important topic, right? So here px and dx are polynomials. Dx is our divisor, which cannot be 0. Then there exist two polynomials, qx, which is the quotient, and rx, which is the remainder. Rx has a special condition. Remember this. This is very important. Rx is either 0 or 1 degree less than dx, or the divisor. So Rx can be 0, or remainder can be 0, or remainder has to be what? 1 degree less than the divisor, right? So then this is the division algorithm form. First form of division algorithm is dividend divided by divisor equals quotient plus remainder over divisor, right? That is the first form. Then the second form is where we get rid of dx from the denominator. So multiply everything by dx. So you get px equals q of x times d of x plus r of x. Second form is the one we are going to mostly use when doing problems. Okay, remember that. This form, second form, right? So what is p of x? Dividend. Q of x is quotient. D of x is divisor. R of x is what? R of x is remainder, right? So when it is in the second form, there are some properties of this second form we should know, right? So let's suppose px degree is what? Let's say px has a degree 6. Then this term qx times dx will have the same degree. Remember that qx times dx has to have the same degree as px. Okay, so when you write a polynomial in the second division algorithm form, p of x degree has to match q of x times dx degree, right? So that is an important thing to notice, right? Then let's suppose divisor is what? Divisor is degree 2. Then what should be the quotient degree? We know what? Qx times dx should be what? 6, no? So if divisor is 2, quotient has to be what? 4. Because we want, when we multiply, to get a 6th degree. So remember this also. You have to know how to get the degrees correctly. Then what is Rx degree? It's either going to be 0 or what? 1 degree less than the divisor. 1 degree less than the divisor. So it's a degree 1. So the general form of this remainder is going to be what? Ax plus b, because it's a degree 1 polynomial, right? So let's do another example. Let's say p of x is degree 7 and dx is degree 3. Then qx has to be what? Qx has to be degree 4, and rx is going to be what? 1 less than the divisor is third degree, no? So then Rx has to be second degree. It has to be second degree. So Rx can have what form then? Ax squared plus bx plus c. It's a quadratic, no? Second degree means quadratic. So the remainder in general will have that form if the divisor is 3, degree 3. And what is the quotient's form? In this example I have given, it's a fourth degree, no? So the quotient has general form what? Ax to the 4, bx cube, cx squared, dx plus e. It's a fourth degree polynomial. So the fourth degree polynomial general form is that, right? Okay, so this is very important. Remember that this property, px degree is same as qx times dx degree, and remainder degree is always one less than the divisor degree, right? Okay, so now let's look at a simple example of dividing polynomials, right? So we want to divide 3x squared plus 2x by x. So what is dividend then? Dividend is 3x squared plus 2x. We want to divide it by x, so divisor is x, right? So this one we can do by factoring, but most of polynomial divisions we can't do this method. We have to do long division method that we are going to discuss next, right? This one it's easy because why? You can factor the numerator, no? You can take x out, right? Then what happens? 3x plus 2 inside, and the denominator also has an x, so that cancels. You get the what? You get the quotient 3x plus 2, and the remainder is what? 0. Remainder is 0. So here you get what? Q of x is 3x plus 2, and the remainder is 0, right? You can write it in division algorithm form. 3x squared plus 2x over x is what? What is the quotient? 3x plus 2 plus remainder over divisor. That is division algorithm first form. Second form is what? 3x squared plus 2x is equal to what? The quotient times divisor plus remainder. Okay. So you should know how to write it in both division algorithm forms, right? Okay, so normally it's not going to be easy like this, so we have to use the long division method, right? So next we will discuss that method, long division method, right? Long division of polynomials, right? I will explain this through an example, right? So suppose I want to divide x squared minus 2x minus 8 by x plus 1. So dividend px is x squared minus 2x minus 8, divisor is x plus 1, right? Compare this with normal number division, normal number long division. So let's compare. Let's start with this. So you put the dividend inside, divisor outside. So what's the first step? You check how many sevens inside of 45. How many? 6. You put it there. Then what you do? You multiply the top number with the divisor and put it under the dividend, right? Okay. So we do a similar thing for long division of polynomials. So you start by putting the dividend inside the division sign. So x squared minus 2x minus 8, and then the divisor outside, x plus 1, right? So here what did we do? We checked how many sevens inside of 45. Okay, so similar thing we do for polynomial long divisions, but that only depends on what? So here we did what? 41 over 7 is 6 whole numbers, right? So here we only look at the leading terms. Okay, leading terms. So we look at the leading term inside and the leading term outside. So we need to do leading term inside divided by leading term outside. What is the answer? X. That you bring here and put it here. So that is the first part of the quotient. Then what's the next step? In normal long division, you will multiply this 6 with the divisor and put it under. So same thing. You multiply x with the divisor x plus 1. What do you get? X squared plus 1. Sorry, x squared plus x. So you put that under the divisor. Put it under the same type of terms. X squared under x squared, x under x. Right. That's the first step of long division. Right. Then what do we do in normal long division of numbers after we get this step? We subtract 45 minus 42. What do you get? 3. Then we check, should we move or no, can we stop? We can stop. No. There's no 7s inside of 3. 3 is not divided by 7. So 3 is the remainder, 6 is the quotient. Right. We stop like that. Right. Now we will apply that same step to the polynomial long division. So subtract. So subtract term by term. So x squared minus x squared is what? 0. So those two cancel. Then minus 2x minus x becomes what? Minus 3x. So be very careful about the signs. So it's what? Minus 2x minus x. So that becomes minus 3x. Right. Then bring the constant down. There's nothing to subtract. So minus 8. Right. Okay. Then again underline the leading term left. Now the leading term left inside is minus 3x. Leading term outside is always going to be that one. So x. So can we divide minus 3x over x? Yes, we can. So we have to go one more step. So you get minus 3. Put that again here. Then what should you do? Again the same step. Minus 3 times the divisor. So that is what? Minus 3x minus 3. Put it under here. So what do you get? Minus 3x minus 3. Then subtract like in the previous step. So minus 3x plus 3x cancels. Minus 8 minus minus plus 3. So minus 8 minus minus 3, which is going to be what? Minus 5. So right, you get there. Right. Now should we continue again? What is the degree of the leading term inside? 0. What is the degree of the leading term outside? 1. Whenever the leading term of the divisor is greater than the remainder degree, you stop. So this is the remainder. Now the remainder degree is 0. Degree of the divisor is what? 1. So then we stop. So that is the stopping criteria for long division. Divisor degree greater than degree of remainder, then stop. Okay. Whenever the divisor degree is greater than the remainder degree, you stop. Right. Then what you get under here is what? That is going to be the remainder. Remainder is minus 5. What you get up here is called the quotient. So the quotient is x minus 3. Right. So then we know the remainder is minus 5. Quotient is x minus 3. Let's write this in division algorithm form. So we write it in both forms. So px is what? X squared minus 2x minus 8 divided by what? Divisor. Divisor is what? X plus 1. So px over dx is what? So let me quickly write the division algorithm first form. Px over dx is equal to qx plus remainder over dx. So qx was what? X minus 3, rx is minus 5. So x minus 3 plus minus 5 over x plus 1. So this is the first form of the division algorithm. Then we'll write the second form also. Qx times dx plus rfx. So the second form is what? X squared minus 2x minus 8 is equal to what? X minus 3 times x plus 1 minus 5, right? So that is how you do division of polynomials using long division. What are the important terms? The leading terms. We decide the quotient terms using leading terms. Okay. Then what is the stopping criteria? Divisor degree is greater than degree of the remainder, you stop. Okay. When they are equal, you can do it. In this step, 1 and 1, so you can still keep on going. Right. Okay. So let's do another example. Right. So we need to divide this. So what is this? This is p of x. This is the divisor d of x, right? So what should we do? We should put the dividend inside. 2x plus 5, 4x to the 4 minus 4x cube. Right. Now notice there's no x squared term, right? So when you are doing long division, if there's missing terms, just write them as 0x squared. Then when you are subtracting term by term, you won't make mistakes because you have a 0 term, 0x squared. So you can put x squared terms under that and do the subtraction. So then you won't make mistakes when you are doing long division. So minus x minus 3. So remember to put a placeholder term for missing terms. So here only x squared is missing. So I put 0x squared. Right. Then the divisor is what? X squared minus 2. Right. So how do we start? By looking at leading terms. So what is the inside leading term? 2x to the 5. You have to divide it by x squared. So you get 2x cube. That I put up here. Right. Then multiply with the divisor. So 2x cube, x squared minus 2 is what? 2x to the 5 minus 4x cube, right? Minus 4x cube. So 2x to the 5, then it's 4x cube. There's no x to the 4 term in the x to the 4 term when we multiply. So put 0 x to the 4 and put the minus 4x cube. Then subtract. Our first step is subtracting, right? So what happens? 2x to the 5 and 2x to the minus 2x to the 5 cancel. This one you get what? Just 4x to the 4. What happens? Plus 0x cube, because these two also cancel. Minus 4x cube plus 4x cube plus 0x squared minus x minus 3. So after the first step we have that. Keep the placeholder terms, the 0 terms. Then you won't make any mistakes when subtracting. Then that is the leading term. So 4x to the 4 divided by x squared is what? 4x squared. So we put that here and then do the multiplication and put it under there. So what you get? 4x squared times x squared minus 2 is what? 4x to the 4 minus 8x squared, right? 4x to the 4 minus 8x squared. So we can put 4x to the 4 here, no x cube term, so 0x cube minus 8x squared, right? Now subtract. What do you get? 4x to the 4 minus 4x to the 4 cancel, no x cube term. What happens to the x squared terms? 0 minus minus become plus, so plus 8x squared minus x minus 3, right? Then what happens? This is the new leading term inside, right? Still the degree is matched. No, this is 2, divisor is 2, so we can still continue one more step. So you do 8x squared over x squared, which is 8. So put it here and do the same thing we have been doing. 8 times divisor, so 8 times divisor is what? 8 times x squared minus 2, so 8x squared minus 16, right? So then put that under here, 8x squared minus 16. So 8x squared, 0x, there's no x term, minus 16, subtract, right? 8x squared and minus 8x squared cancel, minus x minus 0x is minus x, minus 3 plus 16 becomes plus 13, right? Should we continue? Now what is the degree of the remainder? 1. Degree of the divisor is 2. So divisor degree is larger than remainder degree, means we stop. So what is this? That is the remainder. Remainder is minus x plus 13. What is the quotient? Quotient is this one. Q of x is what? 2x cube 4x squared plus 8, right? So we'll write this in division algorithm form, both forms. So you have 2x to the 5 plus 4x to the 4 minus 4x cube minus x minus 3 divided by x squared minus 2 is going to equal to the quotient 2x cube plus 4x squared plus 8 plus remainder is what? Minus x plus 13 over x squared minus 2. So that is the first form. Then the second form, get rid of the denominator. So you will get what? 2x to the 5 plus 4x to the 4 minus 4x cube minus x minus 3 is equal to quotient 2x cube plus 4x squared plus 8 x squared minus 2 plus the remainder, which is minus x plus 30, right? So that is the second form of the division algorithm. And in the second form, notice this. What is this? Dividend. What is the degree of the dividend? 5. And degree of the quotient is what? 3. Degree of the divisor is what? 2. Then what happens? Degree of these two terms multiplied is what? 3 plus 2, 5. So it matches with that. Degree 5. And what is the degree of the remainder? It's 1 less than the degree of the what? Divisor. So that property is very important. So remember that. Okay. Right. Okay. Now let's do this exercise. This is a special exercise, right? Because we are not going to use long division to find remainder and quotient. Let's try to do this without using long division, right? So this is a new method. This is where we are going to use what? Polynomial division algorithm form. So we want to find the remainder and quotient without using long division, right? So let's first identify the terms. This is what? P of x. This is what? D of x, right? So then let's recall the division algorithm form, the second form. Okay, we are going to use the second form. P of x is equal to Q of x times divisor plus remainder, right? So now what is the degree of the dividend? 4. Degree is 4. What's the degree of the divisor? That is 2, right? If the degree of the divisor is 2, we know the degree of the remainder has to be what? At most 1, right? At most 1, because it's going to be 1 less than the degree of the divisor. What is the degree of the quotient going to be? Px qx times dx has to match px degree. So if this is 2, degree of divisor is 2, qx is what? Degree 2, right? So then this is how we do this type of question without long division. Now we know remainder has to be what? Remainder has to be degree 1 and quotient has to be degree 2, right? So then let's write the what? General form of a degree 2 polynomial. Qx has to be degree 2, no? So it's going to be ax squared plus bx plus c, right? And what is the general form of the remainder? It's degree 1, no? So it has to be linear. So with two different letters we will write dx plus e, right? Now set up the division algorithm form and find these 5 coefficients a, b, c, d, e. You need to find those constants. So that is how you do this question without long division. Okay, so dividend px is this 4x cube minus 2x plus 1 equal to what? Now quotient I took as ax squared plus bx plus c, because I know it is a degree 2 polynomial, no? Because the divisor is degree 2 means for it to be 4 degree it has to be a quadratic. So then x squared minus 1 minus 4 divisor plus the remainder. Remainder is what? Dx plus e, right? Because it's a degree 1 polynomial, because it's 1 less than the divisor, right? Now this is what? Equating two polynomials method. So then you can find a, b, c and d and e, right? So that is how you do this type of question without using long division. Okay, right? So now just get rid of brackets and combine the terms. So I get what? Ax to the 4, then what? X to the 4 minus 4x squared bx to the cube minus 4bx cx squared minus 4c plus dx plus c. Now combine like terms and let's compare the terms and get the answer, right? Ax to the 4 minus 4x squared bx cubed minus 4bx cx squared, right? So then you have what? C minus 4a x squared. There's two x squared terms, those two. Then before x squared I have to write x cubed, no? So what is the x cubed term? Only this bx cube. Bx cube. Then I can do the x squared term. So that is c minus 4a x squared. So x to the 4 done, x squared done, x cubed done. So then x terms are minus 4bx and dx. So d minus 4bx. So then those are also done. Then the constants, e minus 4c, e minus 4c, right? Okay, now this is what? This is the equating coefficient problem. So first do what? We'll first do x to the 4. So this side minus 5, this side a. So minus 5 equals a. So a is done. A is what? A is minus 5. Then we will do x cube. X cube is what? On this side 4, this side b. So 4 equals b, right? So b is equal to 4, right? Then we'll do what? We'll do x squared terms. Compare x squared. What is x squared? Minus, no, there's no x squared term on this side. No. So left hand side is 0, right hand side is c minus 4. Okay, so 0 equals c minus 4a. So c is equal to 4a, and we found a, no, a is minus 5, so c is minus 20, right? Then compare x terms. So on the left hand side, x term is what? Minus 2. Coefficient is minus 2. On right hand side, d minus 4b. So minus 2 equals d minus 4b. Minus 2 equals d minus 4b. We found what? We found b. So we can use that. B is 4. So we have minus 2 equals d minus 16. So d is equal to plus 14. Okay, right? Then finally constant terms to get the e value. What is the constant term on the left hand side? 1. 1 has to be equal to e minus 4c. 1 equals e minus 4c. C is what? Minus 20. So minus 20 minus 4 plus 80. So e is minus 79. E is minus 79. Right. So now we can write down the quotient and the remainder. Quotient is ax squared plus bx plus c. What is a? Minus 5, b is 4. So minus 5x squared plus 4x. C is what? Minus 20. Right. And what is the remainder? dx plus e. So 14x minus 79. So that is how you do this question without long division. You can do this using long division also. Okay. If they don't specify a method, here they specified that you can't use long division. If they don't specify a method, always use long division. Long division is easier than comparing this. Less mistakes in that method rather than this method, right? Okay, so now in this lesson we introduce polynomials, some properties of polynomials, and did algebraic operations on polynomials, right? In the next lesson we are going to introduce factor theorem and the remainder theorem, very important theorems in algebra.